Alright, welcome back to section 5.1, and we're now going to solve kind of a difficult problem. And so I've kind of spelled out the steps on how to do it, but before we do that, let me explain what we're going to do. We're going to solve this system of equations right here. And again, sometimes you'll see this symbol like this outside of the equations, but don't read too much into that symbol. That basically just means these are simultaneous equations. So you remember that when we were solving two systems, we had two lines that usually intersected at one point. Well, what we have now are three equations and three variables. And what that means is we're going to have, like, imagine three-dimensional space, okay? So imagine we have an x-axis, a y-axis, and a z-axis kind of coming out of the page, with this kind of being flat. What we're going to have here is three planes, because they're three variables. We're going to have three planes in three-dimensional space, and we're going to try to find the one point, if there is only one point, where those three planes intersect. And instead of having an xy coordinate, we actually have an xyz coordinate for the x, y, and z value where these three planes intersect. Now obviously it could be the case that we have two planes that intersect at an infinite number of points, in which case we'll see that happen when we solve the problem. But basically this symbol means that these are three planes in the same three-dimensional space, and we're going to try to find the xyz coordinate of all three of them. And I'm going to be honest, this is not easy the first time you do it, but I'll try to explain it. Basically, the general strategy is we need to go from three equations and three variables to two equations and two variables. Because if we can get to two equations and two variables, we can solve that just like you've been doing in the previous examples. So you can use either elimination or substitution to do this. So what I'm going to do is I'm going to use substitution. And do you see if we have x plus y plus z equals -7? I'm going to go ahead and solve this equation right here for one of these three variables. Okay? And so I'm going to solve this equation for x. So subtract y and z over, and you get the following. X equals -y minus z equals -7. So take a look and make sure you understand what I just did. All I did was I just subtracted y and I subtracted z to get x equals -y minus z minus 7, all on the right side. So now that I have x equals this, I can substitute it here and I can substitute it here. So let's take the second equation, and it's 2 times x. And we know that x equals all of this. So it's 2 times -y minus z minus 7, there's the 2x, then it's plus 5y plus 2z equals -20. So all I did there was I just substituted this value, because it equals x, for the x right there to give me 2 times all of this, and then the rest of the equation just stays the same. Okay? Let's also do that with the third equation. So I'm going to draw this one over here. So that's going to be negative. And then we have x, which is -y minus z minus 7. So there's -x. And then plus 8y minus 3z equals 1. So now that you see, by getting rid of x, we now have two equations with y and z. And now we can solve those two equations with substitution or elimination. So let's simplify these a little bit. So this one is -2y minus 2z minus 14 when you do the distributive property, plus 5y plus 2z equals -20. And do distributive property on the negative sign gives us y plus z plus 7 plus 8y minus 3z equals 1. Okay, so there we go. Now let's continue. I can combine, again, these are two separate equations. I just kind of have them side by side. So let's add these so we can combine like terms. So that's going to be 3y negative 2y plus 5y is 3y. The z's are actually going to cancel here. That's interesting. And then we have minus 14 equals negative 20. And over here, we can combine like terms. So there's 9y minus 2z plus 7 equals 1. So make sure I did that right. Okay, I did. So normally what we would have here is we'd still have y and z and y and z. That's what's going to happen most of the time. And then you would just use substitution one more time to get one equation with one variable. But since we got lucky here and the z's canceled, I can go ahead and solve this for y, which is what I'm going to do now. Plus 14 plus 14. 3y equals negative 6. Divide by 3, divide by 3. Y equals negative 2. Now when you're doing these, once you have the first number, the problem just kind of falls apart and you can find the others fairly easily. So we have y equals negative 2. So now what I can do is I can take negative 2 and plug it into this other equation I was working on to find z. Okay? Don't plug this back into one of these equations because remember the two z's canceled, so you just get this every time, so that's not helpful. Instead, let's plug it into this equation. So y equals negative 2. Okay, so 9 times negative 2 minus 2z plus 7 equals 1. So that's negative 18 minus 2z plus 7 equals 1. Combine like terms, so we get negative 11 minus 2z equals 1. Add 11, add 11. Negative 2z equals 12. Divide by negative 2. And you get z equals negative 6. So I did that pretty quickly, so go ahead and rewatch that if you need to see it again. But basically we just substituted in the negative 2 to get to our final z answer. Now we know y and we know z, so now we just need to know what x is. And here's what's nice. Once you have these two, once you have two of the answers, I recommend you go back to any of the original three equations, the original three, and just plug in x and y, or y and z in this case, and then you can find out what x is. So what you'll remember is we rearranged this equation to be x equals, so I'm going to substitute into here just to make it easy. So x equals, we have negative y, which is going to be negative negative 2, minus z, which will be, we have minus z, so minus negative 6. Again, notice I have the two minus signs, and then minus 7 on the end. So negative negative 2 is positive. 6 also becomes positive because of the two negative signs. Minus 7, so 2 plus 6 is 8. Minus 7 is x equals 1. So the only point where these three planes intersect each other in three-dimensional space is the point x equals 1, y equals negative 2, z equals negative 6. So I know that's a lot of work for one problem, but that's how you do it. And if you're systematic, you will get the answer every time. So again, substitute one equation for one variable, substitute into the other two. That gives you two equations with two variables that you can then simplify and then use substitution or elimination. Now, how could we check our answer on this? Well, the way you check your answer, like say you're on a test and you really want to make sure you get this problem right, take your x, y, z values and plug them into all three equations, and if they work for all three, you know that's a solution. So let's try it. 1 minus 2 is negative 1. Negative 1 minus 6 is negative 7. 2 times 1 is 2. 5 times negative 2 is minus 10, so that's negative 8. And then negative 8, 2 times negative 6 is negative 12, so negative 8 and negative 12 is negative 20. And here we've got negative x, which is negative 1, and that'll be minus 16, so negative 17. So we have negative 17, and then negative 3 times negative 6 is positive 18. Negative 17 plus 18 is 1. So I did that in my head, but if you wanted to write it out, you could. Just plug in all x, y, z coordinates, and you should get the number on the right. I know that was a difficult problem. In the next video, we'll look at another example of doing this, and I will see you right there. As always, if you have any questions, please make sure that you leave those questions in the comments.